Hello again. I'd like to show you some of the changes I've been making to my code since the beginning of this semester. I've spoken to Dr. Savastrini about around week two of the semester. So whatever changes I've made so far, Project Reborn has been at the front of my mind. So I'm very excited to show you these changes. I've been moving in two general directions. The first one is to make it more easy to curate data sets to train AI from my tool. And the second direction is to make it easier to rapidly iterate different workflows for analyzing images. And the reason for that is Dr. Savastrini mentioned to me that you guys are not yet sure how you're going to be characterizing the grain orientation or the grain sizes. So hopefully, rapid iteration will help you get there faster. Let me share my screen without further ado. Yeah, there you go. Yeah. So the first thing is that I've made some slight changes to the upload screen of this um, of the first upload screen of this tool. The major change is that I made it possible to upload multiple images for the same sample. And the reason I did that is because I saw that you guys have many different micro tools for metrology of your samples when I went on a tour with Dr. Gutierrez this Tuesday. So I thought it would be useful to, if you're, for example, using a atomic force microscope and a optical microscope, it might be nonsensical, I'm sorry, but if you're using an atomic force microscope and an optical microscope to take images of the same sample, you would probably want it to be stored together as an object, like both the images stored under that same sample as an object, and I've made that possible now. So you can define a class, much like Java or Python, where you have multiple images, or it doesn't even have to be images. For example, if you select other, it could be a graph of a stress strain test, like a tensile test, sorry. Um, so yeah, so you can define these spots and then you can save this as a class and then you can add objects of that class. You can upload objects of that class and then you can upload the image. I'm sorry. I'm sorry. Laptop jumped. You can upload images here and then they'll all be stored under the same uh, object, which I think would be make it quite easy to curate AI data sets if you're using multiple different images for each sample or multiple methods of metrology. But it makes stuff a lot slower in later steps. So, I mean, just to go through multiple images instead of one. So for now, I'll just use a singular image. And the image I'm using is actually from the team of Dr. Ali Kasem, who is working on flexible MEMS at Institute Lafayette. Yeah, so this is a screenshot of his samples, and basically what he wanted me to find was the crack density in these samples. So I'll show you how I did that using my rapid iteration tool for designing workflows. Right. But before that, I wanted to show you a different way I've added to add data to an image. So now I can add process parameters to this image, and it will be stored with the image in Google Firebase in the metadata of all these images. So you can actually store the process parameters along with the image, and then you can, download that directly to make a data set to train your AI model. Hopefully that's a useful feature. So you can, for example, I don't know, temperature, you can add pressure, and you can add the volume. I'm just picking random words that come to my head, but yeah, you can define them as floats, integers, booleans. And if you have multiple images, all these you can click apply all these parameters will automatically get applied to all your images, and then you can actually download a CSV template of all of the process parameters on the x-axis and all the images on the y-axis, and then you can very easily just use Excel features like dragging and autofill to quickly fill in your process parameters if you have like 20 images or something like that. Um, I won't show you that feature now. I can show you in person. It's quite robust, but it just takes a bit of time to go through it. So yeah. Um, yeah, so after that, the next thing I've added is this tool called Workflow Builder. So in my first presentation, I showed a um, the tool where you can upload your own code, but this takes it a step even easier than that. So Workflow Builder is kind of like Simulink for AM image analysis is how I'd like to think of it. Or if you've used like fancy editing softwares for videos, that this is also kind of how they function sometimes if you want to apply video filters to them and things like that. So instead of it being a code interface, it's a no code interface where you can just drag and drop blocks to um, process your image. So, as I mentioned before, Dr. Ali wanted me to find the crack density in this MEMS sample that he picked and placed. So, let me show you how I can go about doing that using this tool. So, the first thing I would do is to see if simple Otsu thresholding would work to segment the MEMS from the background. So, I can just drag an Otsu threshold block and I can do show result, and what that'll do is it'll color the parts that are the sample or the parts that are on in the mask and show me that. So as you can see, it's working pretty accurately in my opinion. So I can go forward with this. I think this can be used to find the crack density. And if it can't, there are ways to add Gaussian blur. You can add contrast, and I'm working on adding different tools with a team that I'm working with at Oak Ridge right now for this tool. So they wanted to add to a method known as mean shift, which they've been using to hard threshold their images when there are multiple phases and not just two. Uh, so that's very exciting. But yeah, for now, I think basic Otsu's thresholding is working for this. So I can get rid of the show result tile. And what I'll do is output the inverse mask as well as the mask. And what that'll do is it'll basically just fill in all the tiles that are not filled in right now. So all the cracks would come under that. So I would say inverse mask is probably the better one to use to find the crack density. Um, then after that, what I can do is I don't see any way to automatically define what part of it is the sample and what part isn't. So I'm just going to add a manual mask feature, and that just allows me to draw the mask over the image. And all you have to do is feed in the mask to the manual mask block, and you get a new mask. Let me just show you how that works. Yep. So this is the pop-up that's come for me to manually draw the mask. And since I used the reference mask, which is the original Otsu's mask, this will snap to the edges of the original mask. So that makes it more accurate, I would say. Yeah, let's say I'm satisfied with that for now. It draws a mask like that. So what I want now is the intersection of this mask and the inverse mask, which will be showing all. I'll show you what the inverse mask shows. This is what the inverse mask shows, which is all the cracks and all the background. So I kind of want the intersection of the inverse mask and this mask. So you can use the intersection feature for that. You can combine both of the masks and you can just see your result like this. So yeah, now you can see it's highlighted all of the cracks in this sample. And instead of outputting the right now I'm outputting the mask itself so that I can show it on this image, but I can also output the count of these red pixels, and that can be used to actually calculate the crack density of this image. So as of right now, I don't think this tool is very useful because the selection of features is quite limited. But I look forward to working with teams like yours and as well as the team that I'm working with at Oak Ridge and Dr. Ali's team to add many more blocks to this so that it can become much more useful. Um, Let me stop sharing my screen because that's all I had to show you. Um, yeah, so that was my code. I think I'm very excited about the prospect of Project Reborn. I've heard a lot about the use of AI in physics and material science, and I haven't really interacted much with it. and I can't really say whether I'm excited by it or not, but I'd certainly really like to explore it. I think that the idea of exploring it is very exciting. And, ever since Dr. Savastrini told me about Project Reborn, um, I've just been ecstatic at the opportunity to learn more about this field. So yeah, I really look forward to working with you guys, and hopefully we can develop this tool together. Thank you very much.